Hello. Welcome to my channel. If you are studying electrodynamics and working through Introduction to Electrodynamics by David J. Griffiths, you are in the right place. In this series, I will be solving every single problem from chapter number 7 Electrodynamics. Step by step solution will be given. Whether you are preparing for exams, revising concepts, or just wanted a deeper understanding of the subject, this playlist will help you out, okay? So make sure to subscribe and hit the notification bell so you don't miss any of the upcoming solution. Let's get started with problem number first of chapter number 7. So getting with problem number first, okay? And this problem says that we have two concentric metaspherical shell, one of radius A and other is of radius B respectively, and they are separated by weakly conducting material of conductivity sigma. Here we can see this black material and this material has conductivity of sigma. Now the part first of this problem says which is A, and this is that if we maintain a potential difference V, okay, between these two surfaces, what current flows between from one to another, okay? So this is part A. The part B says that what will be the resistance the black material offer to the current, okay? So B says that R is unknown, okay? And the part C says that if B is far more greater than A, then this radius is irrelevant, so we shouldn't consider this when radius B is far more greater than A. And how do you account for that? We will see this in the solution. So exploit this observation to determine the current flowing between two metal surfaces, each of radius A immersed deep in the sea and held coiled apart, if the potential difference between them is V. Okay, so we have two material here, okay, two metal spherical shell, each of radius A, and what will be the resistance, so the current flowing between these two materials? We will find this if potential difference is V, okay? So let's move toward the solution. The solution for A we have given that the potential difference is equal to V, okay, and conductivity is sigma between the material. Now the required thing is current between the spheres, which is I, which is unknown here, and we go for the solution. Okay, let's see. uh, First of all, we know from Gauss's law that the potential the electric field between these two surfaces is given by 1 divided by 4 pi epsilon naught, and here is q divided by r in the direction of radius, okay, so r square here. Now we see this is our equation 1, okay. From Ohm's law we know that J is equal to sigma into E. Say this is equation 2. Now we know that current density J here is, we can write it is integral of J dot dA, okay, and we know we put the equation 2 here, which will become sigma E dot dA. Now this is constant, so we will bring this out of the integral, okay, and this will become sigma and integral of E. Now just wait for E dot D, okay. Now we will put equation 1 here, say this is equation 3. Now put equation 1 in 3, put 1 in 3, we will get I equals to sigma, okay, which is conductivity, and integral over E dot dA, where E is 1 divided by 4 pi epsilon naught, okay, into q divided by r square, and here it is in the direction r, and dA is also in the direction of r, okay, because it is a sphere and the sphere area is also in the direction of radius. Now this, the dot product will be cos of 0, and cos of 0 is 1, okay, and we will bring the constant uh, out of the integral, okay. So it will become, the current will become sigma, okay, into q is also constant, and here we have 4 pi epsilon naught, radius is also constant, okay, radius is constant, and the only thing that varies here is we will integrate over the area, okay. So this is dA, and this is a close integral, and dA is, what is the area of a sphere? The area of a sphere is 4 pi r square, okay. So this r square and 4 pi will cancel out, okay, and we will left with only I will be equals to, here we have left with sigma q divided by epsilon Now we have found that I is equal to sigma into q divided by epsilon naught. Say this is equation number 4, okay. You see here we are missing one thing, that q is unknown here, okay. So now we have to find q, how much charge is there, okay. Then we can find the real current. So let's see, we have to calculate work from voltage formula, in which we have to integrate the electric field with respect to r from point from A to B, okay. So this is minus B to A, okay, and this sign is purely conventional, okay, and this is E dot dl, okay. Now you see here we have two spheres. The distance between these two is along the radius path from point A to B, okay. This radius is A and this radius is B, so this is from A to B, okay. Now and we integrate also from upward to down here, so from B to A, okay. And electric field here is also known, that we have seen 1 divided by 4 pi epsilon naught into q divided by r square, and it's in the direction of r, and dl is dr in the direction of r, okay. So let's see, let's put this value here, minus from B to A, and we can see here electric field is 1 divided by 4 pi epsilon naught into q divided by r square, and where we put dr here, there's not a dot, okay. So we will dot r, the dot product of these is 1, okay, because the angle between them is 0. So V is equal to pen. Now q divided by 4 pi epsilon naught, they are constant, and we only have to integrate, this negative sign will be there, so from B to A, and we have to integrate it like this, okay. So this integral here is integral from B to A, from B to A of 1 divided by r square into dr is equal to r into minus 2 plus 1 divided by minus 2 plus 1, okay. And the limits are from B to A. Now this will become r minus 1, okay, and this is also minus 1, and limit from B to A. By putting the limits, we see here that this will become, first of all we just bring it in original form, this will become 1 divided by minus r, and from B to A limits, okay. And then we put limits here, so this will become, if we bring the minus outside here, this will become upper limit minus lower limit, so 1 divided by B minus 1 divided by 1 divided by A minus 1 divided by B, and this minus and this minus, so we will just put this value here, okay. So V become minus q divided by 4 pi epsilon naught and this value is here is minus 1 divided by a minus 1 divided by b. Okay, this negative will cancel each other, and this the whole answer is q divided by 4 pi epsilon naught. Okay, 1 divided by a minus 1 divided by b. Now to find the q, we divide this and multiply this both inside, and what we get here is like the main equation here is v equals to q divided by 4 pi epsilon naught and 1 divided by b minus 1 divided by 1 divided by a minus 1 divided by b. Okay, so we will divide this and multiply this on both sides, so this will become q is equal to 4 pi epsilon naught. Okay, 4 pi epsilon naught, and this is voltage, and this is 1 divided by a minus 1 divided by b. Now we put these values in this equation for, okay, let me erase this. If we say this is equation 5, now put equation 5 in 4. Now if we put equation 5 in 4, we get I equals to sigma divided by epsilon naught will be here, and the q, instead of q we will put this value, which is 4 pi epsilon naught, and this is voltage divided by 1 divided by a minus 1 divided by b. Now epsilon naught will cancel each other, and we left with I equals 4 pi sigma, okay, divided by 1 divided by a minus 1 divided by b, and this is b. Okay, so this is the amount of current that flows from a to b. Okay, current flowing is I equals to 4 pi sigma, okay, and b into divided by 1 divided by a minus 1 divided by b. Now this is the amount of current flowing. Okay, so by comparing it to Newton law, we can find the part 2 of this equation, so this problem, which is to find the resistance. Okay, now if we compare, let's see, this is equation 6. Compare 6 with v is equal to IR, from which we can say that I is equal to v divided by R. Now if we see there, this value is equal to 1 divided by R. Okay, so I is equal to, we can say this is voltage, and this value is 1 divided by R. Okay, and so 1 divided by R equals to 4 pi sigma divided by 1 divided by minus 1 divided by b, and so R will be equal to 1 divided by 4 pi sigma into 1 divided by a minus 1 divided by b. So this is the resistance that the material offer to the current, okay, between the spheres. Now this resistance is equal to equation number 7. So this represent the resistance that the material of conductivity sigma offers. Now as we seen that resistance is 1 divided by 4 pi sigma and 1 divided by a minus 1 divided by b. Okay, we calculated this resistance. Part C says when b is far more greater than a, then R equals to what? Okay, so we can say R is equal to 1 divided by 4 pi into sigma, and this is 1 divided by a minus 1 divided by, when we divide 1 by a very large value, let's say is infinity, okay, so this become 0. So the resistance become 1 divided by 4 pi sigma, and this is 1 divided by a, so 1 divided by, we can write this like, okay. Now the second part is we have to find the conductivity, the current flowing, Okay, in this case we have two sphere here in the sea water, so we have to find I flowing here. Okay, as we see that here we have two spheres. Okay, since we have two spheres separated by a long distance, so each sphere behave as a separated conduction path. So the total resistance between them is not R, but the total resistance will be resistance of this plus resistance of this. Now this resistance and this resistance are given by equation 8. Okay, so we have to find it. The total resistance will be equal to, so if we say this will become 2R. Okay, so we just multiply 2 here, so this 2 divided by 4 pi sigma into A. Now this will cancel and this will become 1 divided by 2 pi sigma into A is the total resistance here. So we put it in the formula of V equals to IR, or I is equal to V divided by R. Okay, so let's say this is equation 9 and this is 10. So we put 9 and 10. Okay, so we put equation 9 and 10 and we get I equals to 1 divided by R here. So 1 divided by R, let's see, V 1 divided by 2 pi sigma into A. Now this will become here, so this is 2 pi sigma A into V. So I flowing here from this sphere to this sphere is 2 pi sigma A when potential difference V is applied. Now this is the final answer of the equation. If you have any doubt about this problem, okay, let me know, so I will respond as soon as possible. And if you want us to do any specific problem, so please tell us in the comment box. Okay, we will approach that problem, and please subscribe to my channel. Thank you for watching and being patient. Goodbye.